Assalamualaikum and hi everyone, this is Dr. Shazira. In this video, we are going to be discussing the power method. Power method is an iterative method used to determine the dominant eigenvalue of a matrix, okay, which is the eigenvalue with the largest magnitudes, or we say in absolute value form. All right. So, for example, if we have a matrix A 3 by 3 dimension here, and suppose these three eigenvalues are given by 5, -7, and -3. Okay. So, in this case, the dominant eigenvalue or the eigenvalue with the largest magnitude is this guy here, the second one here. Lambda equals -7 is the dominant eigenvalue. All right. Because in order for you to determine the dominant eigenvalue, you are basically looking in terms of absolute value. So 5, +7, and +3. But when it comes to the writing, okay, you say that therefore the dominant eigenvalue of a matrix A is -7. So you take the actual sign of the eigenvalue. Okay, so put -7, okay, in your answer. But you take the absolute value just to identify which one is the largest. All right. The power method can be used under the following conditions. Okay. The first one, only the largest eigenvalue is desired. Okay, it means the power method only can be used to determine the largest eigenvalue. Okay, we cannot use the power method to determine the smallest eigenvalue, okay, or the eigenvalue in the middle. Okay, so it is used only to determine the largest one, okay, the dominant eigenvalue. And the largest eigenvalue must be real, it cannot be complex eigenvalue. Okay, and the formula is given in by this expression here, vk plus 1, where v is the eigenvector, equals 1 over mk plus 1. Mk plus 1 is basically the approximation to the eigenvalues. A is the matrix, and V again is the eigenvectors. Okay, and steps of solution basically 1 to 6 here, and I will explain in details when it comes to the example after this. And it is recommended for you to have your answer in this kind of table forms. All right. Consider this example, okay, where you are given this matrix A here, and your aim is to compute the dominant eigenvalue, okay, dominant eigenvalue lambda 1 of matrix A, and also its associated eigenvector V. Okay, so two things, okay, lambda 1, the dominant eigenvalue, and the associated eigenvector to that dominant eigenvalue. Okay, and you're supposed to be given the initial eigenvector, so V naught is given here, and stop the iteration when you satisfy this stopping condition, and do the calculation in 3 decimal places. All right, so first thing first is to have your table. The table consists of iteration number k, vector, eigenvector vk, and a vk, mk plus 1, and the stopping condition here. Okay, and the power method formula is given here, vk plus 1 equals 1 over mk plus 1 times a vk. So in terms of calculation, the steps of the computation basically start with this: a times v. So this is your first step. Your second step is to determine m, okay, mk plus 1 over there, and with those two, okay, after the two computation over there, and only then you take you get the left hand side value, which is, so that one is your third step. Okay, so the initial eigenvector is supposed to be known, okay, from your problem, okay, that is given by 0 0.5, 0 0.8, and 0 0.5. And then, okay, so your first step is to compute AVK. So we are going to do this by calculator. We are not doing the manual calculation because the calculator will help us to speed up the calculation. In the calculator, we are going to use mode matrix. Okay, so mode matrix is number 4 here. So number 4. And then we want to store the matrix A here. Okay, so we want to store matrix A and also the eigenvector V, right? So define matrix A. So choose number 1. Number of rows is 3. Number of columns also 3. And input, okay, the elements of matrix A. All right, so that is your matrix A. Okay, next is to store the eigenvector V naught. Okay, so use another matrix. All right, so define a new matrix. So 1, so we can use matrix B to define our eigenvector V. So use number 2, number of rows is 3, column is 1. So we put 0 0.5, 0 0.8, and 0 0.5. So that is your um, eigenvector V naught. Okay, so this is matrix B in the calculator. All right, so back to your table here. So the first computation is A times V. So A is the matrix A in the calculator, but V is the matrix B in the calculator. All right, so option matrix A, so 3 times matrix B, okay, because B is your V, okay, in your problem. So call matrix B, which is number 4. So mat A times mat B, so you have 3.1, so put here. So 3.1, 6.3, 6.3. So that is your AVK, mat answer in the calculator. Alright, so next is to identify, step number 2 here is to identify mk plus 1. So mk plus 1 is determined by looking at the elements of A times V here. So you look at this column, which one is the largest in terms of absolute value. So you have 3.1, 6.3, 2 times here. So the largest here is 6.3. So right here, mk plus 1 is 6.3. Okay, and at the first iteration here, you don't have the difference between two consecutive m yet. Okay, so just put dash. All right. Next, okay, computation number 3. So step 3 is to compute your vk plus 1 here. So vk plus 1, so your current v is at k equal to 0. So the next vk plus 1 is supposed to be v1 here. Okay, so by computing this and this, okay, 1 over mk plus 1 times avk. So in your calculator, it's basically this avk, okay, this avk, which is this one here, okay, in your calculator, in your current view. So that is avk, your current view here, math answer here, okay, is actually your avk. So you want to divide with mk plus 1, so you can simply press the divide by here or division here, okay, over mk plus 1. So your current mk plus 1 is 6.3, so put over there 6.3. So you have a new math answer here which correspond to your column number 2 here, vk. So it is actually this guy here, okay, the third step here. All right, so it is actually k equals 1. Okay, so v at the current iteration is 0.492, okay, in 3 decimals, and then you have 1 and 1. Okay, okay, so settle for 1 iteration. Okay, so up to this third computation. So now you want to repeat again, so starting with this one here, avk, but your current v is no longer this one. It's no longer the initial eigenvalue, eigenvector. It is now the updated V, which is your current view in your calculator. So don't press any button, okay, just let it be. So math answer over there is basically your V, your current V. Okay, so we are just going to use the math answer. We don't need to store another matrix, all right, in the calculator. All right, so A times V. So we need to call back our matrix A. Okay, A didn't change, so matrix A, so number 3 times, okay, VK. VK is your current answer in your calculator. So we call the current or math answer here. Okay, so just scroll, okay, to the bottom. So you will find the math answer. So press 1. So math A times math answer is basically A times your current eigenvector, which is this one here. Okay, so press equal. So you have those values. Right, so that correspond to the third column here. So 2.968, okay, in 3 decimals, and then you have 7.984 and then 12.50. So carefully here, you need to check one by one here to determine, up to 3 decimals. Okay, so you need to look here, so in 3 decimals. Okay, but for this one, all right, so it is actually 5079. So in terms of 3 decimals, it is supposed to be 12.508. Okay, so careful with that, because what you can see, okay, in terms of matrix here, it is not the complete length of the answer. So you need to scroll one by one to see the actual length of the elements of mat ans. Okay. Okay, now repeat again the step number 2 here. Mk plus 1 is determined by looking at the largest eigenvalue out of these 3 elements here. So in terms of absolute value, it is 12.508. Okay, I want to draw your attention on this part here. So let's say, okay, instead of negative 12.508, let's say you have negative somehow, just the same. All right, so when it comes to the mk plus 1, so in terms of absolute value, so you have positive 12. But when it comes to writing, you need to take the actual sign, okay, if you have negative somehow. Okay, so I hope you're clear on that. All right, because sometimes students miss that part. Okay, students tend to write the positive one. Okay, but for this specific example, it is okay because the actual sign is positive anyway. Okay, but in case it is negative, so you need to write down the actual sign when it comes to the writing mk plus 1 here. Okay, so I hope you are clear on that. And then now you can check, okay, you can compute the absolute of the current m minus the previous m. So 12.508 minus 6.3, so you have here 6.208. Okay, you can compute the difference between two consecutive m. And we can see now this is still far greater compared to this 0.05. So it means we need to proceed. Okay, so up to this, you are basically done up to this second computation. So we need to proceed to the third one here to get vk plus 1. So your vk plus 1 is supposed to be the third row, okay, when k equals 2. Okay, so what you do, avk divide with mk plus 1. So avk is your current view in your calculator, so you divide by your current m, okay, which is 12.508. So that is your latest, or your current v now, vk plus 1. Okay, so this is 0.237. Okay, and then next you have 0.638, and last element would be in 3 decimals, that should be 1. Okay, so you have 1. All right, so next, okay, we um, proceed again. Okay, repeat the process starting from 1 here, and then 2, and after that 3. Okay, so we compute avk. So your vk now is your current view in the calculator, your math answer. So we want to call a, okay, and then multiply with the math answer. Okay, so you find or call back the matrix a, so 3 times, okay, your current answer. Okay, so call the math answers. So number 1, so you have those values. So 1.226, okay, and then you have 5.305, okay, and then you have 12.401. Okay, so in terms of absolute value, so your mk plus 1 is supposed to be 12.508. sorry, 401. And then you can compute the difference between two consecutive m. That is 0.107. So you can see you still cannot stop here because it is far okay, greater compared to your epsilon here, 0.05. So it means you need to proceed. Okay, so next is to determine, okay, your vk plus 1 here. So step number 3 here. So you have 1 over mk plus 1 times avk, or basically this avk divided with your mk plus 1. So your AVK is basically your current view in your calculator. So you just need to divide with your MK plus 1, divide with 12.4, sorry, 401. Okay, and the answer would be at the next row, you have 0.099. Okay, so next is 0.428, and then you have 1 again. Okay, so next is to repeat, okay, one more time. So computation number 1, avk. So your avk, so you call your matrix A, and then you multiply with the current v, which is your current view in the calculator. So call matrix A, so 3 times mat answer. So find the mat answer, so 1. Okay, so careful. Okay, don't press any, don't simply, press any button in your calculator because you want to take the mat answer. Okay, so if you, ruin your current view, then that would there will be, maybe a different mat answer. All right, so just careful with your calculator. Okay, don't simply press any button unnecessarily. Okay, so you have now 0.251. Okay, and then next element you have 3.764, and then 12.329. Okay, so again, mk plus 1 is the largest eigenvalue. So you look at these 3 elements here, which one is the largest in terms of absolute value. So this is 12.329. Okay, so again, compute the absolute, value of the current m minus with the previous m, and then you will have, okay, you can do basically 12. So you can compute here 12.329 minus 12.401. Okay, this one is okay because it is basically doesn't ruin your matrix. Okay, so because this is just subtraction of two numbers. Okay, so 0.072. Okay, so again it is uh, greater than 0.05, so it means, okay, you need to compute vk plus 1, so which is supposed to be in the next row. So now vk plus 1 is avk, okay, which is your basically your latest mat answer in your calculator. Okay, even though you cannot see here, but it is still there. Okay, mat answer is still there, divided with mk plus 1. So you just can call the mat answer, okay, 1, and divided with 12.329. Okay, so you have a new mat answer. That would be your current v. Then you have 0.020. Okay, so 0.02. Next element is 0.305. Okay, and lastly 1. Okay, all right. So compute again avk. So avk, so you call your matrix A times vk. So your current v here is your current view in the calculator. So option matrix A times the mat answer. Okay, so 1. So you have negative um, 0.307, so 308. Okay, and then you have 2.873, and then 12.285 somehow. Okay, so now your current, so your mk plus 1 now, okay, the largest the largest absolute error, okay, sorry, the absolute value, okay, out of these three elements here, so it is 12.285, and then you can compute the absolute value of the difference between two consecutive m. So you have 12.285 minus 12.329. So you have, in terms of absolute value, so 0.04. So basically, yeah, you already satisfy this stopping condition here. So it's basically you can stop here. Okay, you can stop here. Okay, but you must complete your calculation. Okay, because up to this, you are actually up to the second computation here too. So you need to proceed to this one. So get k equals 5. So get your associated eigenvectors. So you need to complete one more step, okay, to complete your iteration here. So compute vk plus 1, which is avk divided with mk plus 1. So avk is basically your latest math answer in your calculator. So option, find your math answer. So 1 divided with mk plus 1, so which is 12.285. Okay, so you have negative 0.025. Next element would be 0.234, and then last one is 1. Okay, so that is the complete iteration. Okay, so you can stop over there because you already satisfy this stopping condition here. So remember, one complete iteration should be somehow up to the new new rows. Okay, but when you stop, it means you don't have here. Okay, because the your computation basically start, yeah, with this column. So the complete, yeah, the complete one cycle should be up to this one here. Okay, vk plus 1. Okay, so then we need to write down our dominant eigenvalue. Okay, so the dominant eigenvalue is lambda 1. Okay, so that is approximated to the latest m that you have in your table, which is m5 basically. So you are here, your latest m is here. So this 12.285 is basically M5. It's not M4, even though you can see here K is 4. But for this column, this is actually MK plus 1. Okay, so 12.285 is basically M4 plus 1. So M5. Okay, so that is 12.285. And then the associated eigenvector, which correspond to V1. So this one is the latest V that you have in the calculation. So V5. Okay, so that is 0. Negative 0.025, 0.234, and 1. You can put transpose over them. Okay, so that is the complete answer, complete solution. So you have dominant eigenvalue lambda 1 and also the associated eigenvector to your dominant eigenvalue. Okay, so that's the flow of the computation for the power method. Okay, the answer might be slightly different. Okay, especially at the last number in your calculation here. It would be slightly different if you do the manual calculation. Okay, by manual calculation. The manual calculation basically for k equal to 0, so you will do manually, so you will compute a v 0. So you are going to write down your matrix A here, you are going to write down your v 0, okay, and again somehow here you will have 3.1 basically based on the table here, and we tally with the manual calculation that's supposed to be how it works, okay, in the manual calculation. So out of these three, you compute your mk plus 1, um, mk plus 1, which means m1, so this is 6.3, and then the next computation is vk plus 1, which is v1 is 1 over m1 times a vk, so this is 1 over 6.3. So you put your matrix A here, and then you multiply with your current v, which is 3, sorry, so this AVK here is basically your 3.1, 6.3, 6.3. So you have your V1, which is in the calculator, in the table we have 0.49211. So that is how you do, the calculation. Okay, if you use the manual calculation. So you will repeat again k equals 1. So compute a v1 now. So you write down your matrix A. Your v1 is the latest v that you have in the previous calculation. Okay, 1, 1, and so on. So you repeat the process, okay, determine your M2, so on and so forth. Okay, so this is the manual calculation, which somehow, require a little bit more time, okay, compared to, the calculation straight away by using the calculator. But by using the calculator, you need to be very careful, okay, in terms of mat answer, mat A, and so on and so forth. Okay, but with the enough exercises, okay, using the calculator, I think you can understand how it works, okay, in terms of the use of calculator. Okay, but again, if you're comfortable with the manual calculation, you can proceed, but try to practice so that you can, really fast on this, okay, because you are not going to spend much time on this. So this one should be completed within not more than 15 minutes.